Okay, so let's start by looking at this diagram of Newton's cradle on page 3 of your project. And here we've got the cradle, and I want to remind you that we decided to do a couple things. The before conditions, the initial conditions, we're drawing with solid lines, and the after, in other words, the response conditions, we're drawing with dotted lines. So we're going to try to stick with that in the future. And then I asked you to come up with 3 questions that we could investigate about the cradle. And ideally, everyone would have their own Newton's cradle at home, and you would, lift the balls up and drop them for yourself, but that's not going to work right now. So I'm going to run a bunch of different experiments, and the idea is that those will answer most people's questions, and then at the end, maybe you have another question for me to run the experiment here. So basically, your questions are going to ask about how Newton's cradle is going to demonstrate momentum. And remember, momentum has 2 parts. Oh, and there it is right there, huh? So at the top of every page, momentum is the mass times the velocity. And the way we will represent that, or the way we will modify that with Newton's cradle to study these 2 major factors, these 2 big variables. Mass, we will manipulate the number of balls that we drop, and that will change the mass, which in turn should change the momentum. For velocity, unfortunately, we do not have a way to measure this directly, how fast the balls are moving. If we had a radar gun, we could measure it, but we don't. So instead of measuring velocity directly, we're going to measure the height that we drop the ball from and the height that the ball responds. And we are going to assume that the height reflects the velocity. Basically, if you drop it from higher up, it should end up accelerating to a higher velocity. Similarly, if it rises higher up in the response, we're going to assume that it had a higher velocity. So we're not measuring velocity directly. We're going to use height to represent velocity. Mass we can measure directly. Okay, and then we talked about our initial conditions and our boundaries. So we're going to be looking at that. What we're really interested in is the velocity as the ball enters this boundary, and the velocity as the ball exits the boundary. Same thing for mass. So we're ignoring the influence of my hand out here and the energy that powered my hand from my food and the energy that powered the food from the sun. We're ignoring all of that. It would be an infinite chain if we kept going. We have to draw a boundary somewhere. So we're going to draw it around the edge of the Newton's cradle and just consider the entry of the ball and the exit of the ball. By counting the number of balls, we'll know the mass, and by measuring how high they go, that's going to give us an estimate of their velocity when they entered or their velocity when they exited. So, last time I asked you to design 3 experiments right here. I designed one as a sample, and this is going to be our first experiment that we conduct today. We're going to follow these procedures. And I asked you to take the 3 questions that you asked on this page, the bottom of page 3, and basically transfer those to page 5. So whatever your first question was is going to be experiment 2. And that might be different for you than it is for somebody else. Whatever your next question was, that's experiment 3. And whatever your final question was, that's experiment 4. because experiment 1, everybody is going to be the same. It's going to be mine right here. And so as we actually conduct these experiments today, you may do them in a different order than you've written them down. You might also end up skipping one because it's not one of your questions. So whenever I am doing an experiment that does answer one of your questions, that's when you're going to record your data. And the goal was to have your procedures already written out by now. And if you haven't done that, you're going to need to go back and do that. So my first question, what happens when one ball is dropped from a medium height? And we're going to call that medium height 3 centimeters. In fact, we're probably going to consider that a low height. We're only going to do 3 centimeters or 6 centimeters. So one more thing about your questions. Because we had really these two different variables, mass and velocity, I wanted one of your questions to really focus on changing the mass. Only change the mass for one of your questions so we can isolate that influence. So one of your questions basically would change the number of balls, but still lift it to the same height. Another question should focus on only changing velocity so we can isolate that variable. So that's where you would change how high you're lifting the ball. That would change its velocity. And then you have a third question where you can manipulate whatever you want. And in a lot of ways, you have some variety in how you manipulate the mass too. It could be 2 balls, 3, 4, 5, whatever. And same thing with velocity. Okay, so that's what I'm hoping for your questions is one altered mass and another altered velocity. Okay, so before we actually start running the experiment, let's move to the data table. Page 6. So for each experiment, here's experiment 1. This is my question. For each experiment, you are going to need to repeat it 3 times, or we're going to repeat it 3 times. I will actually probably do it more than 3 times to give you a chance to make sure that you've actually seen what's supposed to happen. Let's see, I'm going to change this to Arial and I'm going to make it bigger so you can see it. There we go. So go ahead and fill in trial 1, 2, and 3, not 33. 1, 2, and 3 for the first experiment. So I'm going to do this 3 times. And actually, I will do it more than 3 times to make sure you got a good measurement. Once you get a good measurement, then you're going to record your data here. Actually, this is all initial conditions. So this is before we even begin. This is at the beginning. It's the initial. And we're going to repeat the same thing 3 times. So this will also be 3 centimeter drop height. And this will also be a 3 centimeter drop height. In every case, I'm going to drop it from the left. So I can fill that in. And for this first experiment, every time I'm going to drop 1 ball at a time. So I can copy that down. Now we have this other category here, total mass. What is the total mass moving in the system? Well, I'm only moving 1 ball. And maybe you remember that I measured the mass of the balls last class, and it was like 67.5, but I think we'll just round that off to 68 grams. So that's the mass of a single ball, 68 grams. And if I'm only dropping 1 ball, that means my total mass is just 68 grams. If I dropped 3 balls, I'd have to multiply 3 times 68, right? Because we want to find out the total mass that's involved here. And again, I'm repeating the same thing 3 times. So the initial conditions are all identical every time for all 3 trials for each experiment, right? These should all be the same for experiment 1. For experiment 2, we're going to change some of these. What's going to be different will be the response height. Yeah? Potentially the number of balls. You're going to, when I drop the ball on the left of the Newton's cradle, you're going to watch on the right, and you're going to measure how high it goes on the first swing, and you're going to type it in here. You also have to record whether it was the right or left side of the cradle. You have to record the number of balls that responded, and then you find the total mass, which once again is the number of balls times 68, because that's the mass of 1 ball. All right, so I think we might be about ready to begin. So ideally, at this point, you have filled up your screen with this image because you need to be able to measure how high these balls swing. So if you haven't done that, please do so. And I see some other people have arrived. I need to ask you here on time when the class begins. But don't get me wrong, I'm mostly happy that you are here. But I do want you here on time, okay? All right, so I'm going to move this over a little bit so you can really see the response measurements. Let me see, I'm going to do it like this, I think. That's better. Yeah. So when the ball comes over here, I'm going to release it from this side, right? And then your goal is to measure how high it swings on this side. Yeah? And then you're going to record that response height back on your paper. So you're going to go back and forth between this view and your paper. All right, so here we go. Question 1, 1 ball from 3 centimeters high. I'm going to give you a little countdown so you can look and measure how high it is. I'm measuring from the bottom of the ball, so that's what you want to try to do. 3, 2, 1. And again, only measure that first response, because as it keeps swinging, it's losing energy, so it's losing momentum. The energy is being converted into sound and a little bit of heat, and also these balls aren't really lined up very straight, so the transfer of energy is not very good. I'm going to do this a bunch of times, and you need to make sure you get at least 3 of their response heights recorded. Here goes again. 3, 2, 1. Next one. 3, 2, 1. So again, this is for question 1. It is 1 ball dropped from 3 centimeters high, measure to the bottom of the ball. I'm going to do it a couple more times just to make sure you got your measurements, because I know it's kind of quick. 3, 2, 1. One more. 3, 2, 1. Please give me a thumbs up if you got your 3 measurements, or maybe more importantly, let me know if you're missing. Do you need me to do it again? Anybody out there need a repeat? Okay, that's good. Thanks, Kitali. Thanks, Gus. Thanks, David. All right, so let's go back to this. So you should have filled in your response height here, huh? And I think we're probably in agreement that our response was on the right side, so that should be here. How many balls responded on the first swing? Should have only been one, which means our total mass is 1 times 68. This is going to be 68 all the way down here, huh? Now, we're going to take these 3 response heights and we're going to transfer them to the next page. So, whatever those were for you, let's say for me it was, I don't know, I called it 2.5. And then the next one I thought was 3. And then I've got really precise and I called it 2.8 or something like that. Let's say those were my measurements. Okay, so what I'm going to do with these 3, and you shouldn't have these written down, you should have written down whatever numbers you had, correct? I'm going to take whatever numbers I have here, or whatever numbers you have here, and we're going to transfer them here to page 7. So I had, I think, 2.5. What did I have? 2.5, 3, and 2.8. Okay. So I transfer my numbers there. Next, you can see that there's a blank space to find the average. So I'm going to put those numbers in my calculator, add them together, 2.5 plus 3 plus 2.8 equals, and then I divide by 3 because that's how many there were, and I have to hit the equal sign again, and I get 2.76, rounded to 2.77. And of course that was in centimeters. Okay, now I just want to point something out here. Look at my average and compare that to these numbers. If you calculated your average correctly, you can always tell at a glance by looking to see, is the average in the middle of all the numbers? Is it bigger than some and smaller than others? Yeah, it's bigger than that, but smaller than that, almost the same as that. So this is a good average. If I'd gotten 3.7, well, that's bigger than all of them. That couldn't be the average. Or if I'd gotten 1.6, smaller than all of them, the average will always be in the middle. That's one way you can tell if you have a good average or not. So I have now checked off that bullet. Okay? Next, it asks me to outline the system boundary. Okay, and remember, you can use a rectangle for this if you like. The boundary is basically the edges, the borders of the Newton's cradle itself. We're only studying what's happening as a ball enters or exits that zone. So now I can check off that I outlined the boundary. Next, draw the initial conditions. Okay, so I need to draw another ball. So I'm going to use a circle. I'm going to try to make it about the same size as the ones that are shown there. And let's see, I'm going to make it a little bigger. Actually, sometimes this stuff is way easier to work with on your computer if you zoom in. It gives you a little more control over these shapes. So I'm going to make it a little bigger to try to match these. It doesn't have to be a perfect fit. That looks pretty close. And let's see, I swung that from not too high up, not too low down. It was from 3 centimeters, huh? So I'm going to try to move this. There we go. I'm going to move it to there. Okay. Now, that's just part of the, oh, that was the initial condition, wasn't it? Yeah, I don't need to draw the string in just where the ball was. I think we'll be fine. So draw the initial conditions, did that. Now draw vectors in it. A vector, remember, a vector diagram is an arrow, and we use an arrow because it includes a direction. So this is velocity, it includes direction. And this is the arrow that I'm going to use to show how fast it was moving. So I'm going to measure 1, 2, 3, and I'm just measuring it up at the top here. I'm going to move it to where I want it, but I want it to be 1, 2, 3 centimeters long. Then I'm going to move it here, showing that the ball was entering the system at 3 centimeter velocity. Again, we're not actually measuring velocity, but it's going to represent velocity. So there's my vector going in, but now I need another vector going out. And this vector should not be 3 centimeters, it should be 2.77. So I'm going to draw another arrow. I'm just going to use the same zone to measure it. 1, 2, a little bit more than 2.5. And there's my other vector arrow, except this one's exiting the system, huh? However, there's one other thing I want to do to this arrow. Remember, we were going to show solid arrows as initial conditions and solid balls, and dotted balls and arrows as response conditions. So if I right click on this and then I click on properties, I can take the style and change that to dots. And I click OK. And can you see that now it's a dotted arrow? Now, some of you might not have the choice of making solid arrows and dotted arrows, so what you could do is make 2 different colors. Whatever we do, don't you think we should probably make a key up here? So let's see, I'm using red, so I better change it to red. And I want to say solid equals initial condition, dotted equals response conditions. So if you want to use green and orange, I had my caps on. I also don't want that to be so big, so I'm going to change it to 10. I'm going to undo this whole thing. So you should make a key at the top here showing what you used for your arrows and so forth. Move that to where it's a better place. So yours might not be solid and dotted, it might be green and orange or whatever colors you used. Okay, I have now taken care of the vectors that indicate movement. Lastly, draw the average response. I'm only going to draw this average, which I've shown with the vector. And so, oh, I know what I'm going to do. I'm going to go back here. I'm going to go back. What I'm going to do is I'm going to click this one. I want to make sure it's the same size. So I'm just going to copy by hitting Control C and paste by hitting Control V. And now I have an identical sized ball to draw on the other side, showing it come out, but I have to make this dotted, or I have to make it a different color, whatever worked for you. For me, I'm going to change it to dotted by right-click, Properties, Style. Then I'm going to click that dotted choice, and there I go. Oop. I don't need that guy. Now there's one more thing I should do here, and that is label on the vectors what amount of, well, we're going to label the height. Ideally, we would label the velocity here, but remember, we're just using height in place of velocity because we're assuming, which I hope is a good assumption, that the higher it goes, the more velocity it had. So we should label those vectors with their velocities. And actually, that should have been 2.77, huh? So finish that up. Then we're going to come back to Newton's cradle, and I am just going to run a whole bunch of experiments of variations on both the mass and the velocity. And you need to record the data that matches the questions you asked earlier. And then if I end up missing one of your experiments, you just tell me what it is and we'll take care of it. Okay, so let me come back here. Are we ready to go? Give me a thumbs up.
We're good.
We're good? Okay, thank you. So, excellent. Question 1 again was one ball from kind of low. What I'm now going to do one ball from higher up. So this is going to be one ball from 6 centimeters. So see if that answers one of your questions. Again, these might not be in the same order that you asked them. So you should fill out the data table to match your questions, right? We're going to do one ball from 6 centimeters. Here we go. 3, 2, 1. And again. 3, 2, 1. Another time. 3, 2, 1. So again, try to measure to the bottom of the ball. It is okay to have like half measurements or quarter measurements. Just change those to decimals. Here's another one ball 6 centimeters high. 3, 2, 1. And I'll do it one more time just to make sure anybody who needed that got their 3 trials worth of data. 3, 2, 1. Okay. Please let me know if you need me to repeat that or if we're good to move on. So the next one I'm going to do is I'm going to go back to only 3 centimeters and I'm going to lift up 2 balls. So I'm changing the mass, but I'm not changing the height on this one. The previous one, I changed the height, but not the mass. Thank you, Josh. Okay, 3 centimeters, 2 balls. So this is a different experiment. Record your data in a different place. Make sure it matches your question. 3, 2, 1. Only measure the first swing. Next trial. 2 balls at 3 centimeters high. 3, 2, 1. Three, 2, 1. And again, 2 balls, 3 centimeters high. 3, 2, 1. Really, these should not be moving at all when we begin, right? 3, 2, 1. All right, I'm going to increase the number of balls. I'm going to go 3 balls at 3 centimeters high. So if this matches one of yours, excellent. Record this data. 3, 2, 1. We're getting to the point now where when I'm holding the balls up, they start to roll around each other, and one of them wants to fall before the others. So we might end up having a trial that we have to ignore. Just like when we were in the gym and we bounced the tennis ball off the top of the basketball, sometimes it went at a funny angle, so we didn't include that measurement. The same thing can happen here. Just because this is not quite a great Newton's cradle, parts of it are a little off kilter. 3, 2, 1. So if it looks like a funny bounce, you can skip it. Like sometimes I've even seen these balls end up getting tangled around each other. So that would not be a good measurement if that happened. Three balls from 3 centimeters. 3, 2, 1. And last time, 3, 2, 1. All right, I'm going to go 2 balls from 6 centimeters. So I'm changing both mass and velocity now compared to our first test. 2 balls, 6 centimeters. 3, 2, 1. It looks to me like this ball in particular wants to bounce out of position, and I think that's because it's not quite in line. Ideally, these are in a perfectly straight line and barely touching. All right, 2 balls, 6 centimeters. 3, 2, 1. Only measure the first swing. Measure the bottom of the ball. 3, 2, 1. One more. 2 balls from 6 cm. 3, 2, 1. All right. So there's a bunch of different variations. I would like you to tell me if you need me to do some other kind of experiment. What else do you need? Is there a question that you would like answered that we have not tested yet? Unmute your microphone. Tell me what you need me to do to finish.
One of my questions was 2 balls from different sides.
2 balls from different sides? 2 balls on each side?
Yeah.
Okay, that's going to be interesting. Okay, so on your data table for initial conditions, you're going to have to write down L and R, correct?
Yes.
Yeah, and then we're going to have to pay attention to if it's both left and right in the response. So I should probably move this over this way a little bit. But then I think for response, only measure on this side. But
Okay.
notice what's happening on this other side. Does that make sense? So we're going to measure this side, but we have to look at this side too. And what was your height? Was it 3 or 6?
3.
Okay. So here we go. 2 balls from both left and right. 3 centimeters high. 3, 2, 1. It's a little tricky. Let me try it from here. Stop that guy from moving. Here we go. 3, 2, 1. Got a little tangled on that one. And again. 3, 2, 1. See if I can do it good. Nope. What should happen? That's what should happen, right? That was better. So let's try it again, paying attention to here we go. 3, 2, 1. That's a better one. And again. Yeah, this one ball is messing us up because it's not in a straight line. And that's not even the one that has the broken string. So there's a couple issues with this particular Newton's cradle. We're going to look at a video of a really good one later. That was a good measurement though. Did you get your measurements? Give me a thumbs up or tell me that you got it. Do I need to repeat it or are we okay? Okay. Does anybody else have a different measurement that they need to get? So let's go back. Let's go back to this. Now, let's just go to here. I want to remind you that we started out on page 3 by asking 3 questions. And these questions should match in 3 other places that we're working on now. We're kind of jumping between one page and another, and we have to make sure that everything matches. You've got your 3 questions here. And then here you've got your procedures to answer those questions. Experiment 2 should answer question 1. Experiment 3 should answer question 2. I know they don't match and that's probably confusing, but that's because I inserted an additional question, right? What happens when one ball is dropped from a medium height? So your questions should match between pages 3 and 5, and they should also match with page 6. Experiment 1 matches my question. Experiment 2 should answer your first question, and so on for experiment 3 and 4. And then your data should also match down here, right? Here's the data for my question. This data should answer question 1 for you. And this data should answer question 2 and so on, right? So I want to make sure that your questions and your answers are going to match. I'm going to zoom out a little bit so we can see the whole page. So this is what your assignment will be for the remainder of the period, which is looking like it's maybe close to an hour. First part of your assignment is to make sure that you did write out questions and that they match the experimental data that you recorded. Now, if you recorded data that doesn't answer one of your questions, that's okay. I just want you to go back and change the question so that it matches the data. One way or another, your question and your data should match. So that's the first thing to make sure you have it good at the bottom of page 3. Then on page 5, you need to make sure you've written out your procedures. You copy the questions from page 3. This is question 1 from page 3, and you write out a procedure. Same thing for the other 2. Here's a procedure that you could use as a guide. The other thing I want you to finish during this time before the end of the period is make sure all your data is complete here. You've filled in all of your initial conditions, you've written down all of your responses, of course, and you've followed up with whether they were to the right or the left and the total mass. Just to make sure we're on the same page here, if this was, I don't know, let's just say 3. If my second experiment had 3 balls, my mass would have to be 68 times 3. Are we good on that? 68 times 3. Let's see. That should be 180 plus 24. Is that right? Clear. 68 times 3 equals 204. Yeah. So whatever the number of balls was that you were measuring times 68 gives you your total mass. And that is true for both initial and response conditions. So I want you to have this done by the end of the period. Next, I want you to have these done by the end of the period. Figure out your averages and draw your vector diagrams. And the last thing I want you to do while it's fresh in your mind, on page 8, I want you to answer this section about how to improve the experiment. Give 2 suggestions for ways to make this better. This is something that scientists always need to do, is look at their data and look at their apparatus and ask themselves, did I really collect that data in the best way possible? What suggestions would I make for someone else doing this in the future? That's what I want you to do here while it's fresh in your mind. And secondly, I want you to answer these 3 questions. These are the answers to the questions you asked on page 3. Okay? Now, obviously, there's more pages to be done. There's even more on this page. You don't need to do this stuff. This is where we're going to pick up. We're going to pick up on Thursday with this part. Okay? So, one more time, I want you to double check the bottom of page 3. Make sure it matches your procedures on page 5. Make sure those match your data table on page 6. And that also matches your vector diagrams on page 7. And finally, answer the first 2 sections of page 8. You have the rest of the period to work on this stuff. If you have any questions for me, please ask. You can stick around. If you need me to run another experiment because we didn't answer one of your questions, we can do that right now. Just let me know. Otherwise, you are free to exit the meeting and work on this stuff for the rest of the period. Hopefully it's clear what I expect you to have done when I see you again Thursday morning. Same time, same place. We're going to pick up where we left off, and you should have all that stuff done. I will write it down and post it on Teams too. All right. Thanks for being here, guys. That's all I have for you today. Let me know if you have questions. Adios.
All right, thanks, Fairley.
All right, later.
All right.
Thank you.
Thank you.
Thanks, Fairley.
See you, Mr. Fairley.
Bye, Fairley.
Bye.
Mr. Fairley,
Yeah.
where can we find these videos, like the recordings of the meetings?
I post them on Teams.
Oh, okay.
Yeah, like I recorded the last meeting. I recorded it and I posted a link right there on Teams that takes you to YouTube recording.
Okay.
Yeah. You won't find it by searching because it's kind of undercover. You have to have the link to get to it.
Okay, thank you.
All right. Take care.
You too.